Okay, so today we've got a Fidelity base station, and as we know, these are very poor performers, but they are very stylish and unusual, and people love them. Transmit power is normally between 1.7 and 3.5 watts, so it's never going to do 4. They never do 4, and there you go. It doesn't matter though. People aren't going to use one of these as their sole method of communication. It's a collectability thing. It's got a knob missing. I don't know whether that's in the packaging. Perhaps if the customer could email me whether that's supposed to be missing. Now there's a possibility our friend in Leeds who does 3D printing, he may well be able to 3D print some knobs, which of course wouldn't be this smooth, but you saw the ones he did on the Rotel 220 for us. Have I got it lurking? No, I've put it away. Which were really excellent, and the knobs are usually always missing. We've got one of ours. We've got one of these in the airing cupboard connected up to the PA system. So if people are within about a mile and a half and they call on 31, it'll come through our tannoy system. But ours hasn't got any knobs on it at all. So it might be I can send some knobs up to him at Leeds from one of our sets and him replicate them. I think that would be wonderful. So we've got a letter with this, which is very nice. I've folded it in such a way that his address isn't there. Many thanks for your videos. Agreeing to look at this. These there will be a second one. That's what I've said in the video. We're expecting 2 of these. He's had a quick look at this, and it seems to be working on the whole. It appears to have had some sort of hose pipe modification. Yeah. Anyway, home mains hum. Yeah, well, it's going to be, isn't it? We'll change some capacitors and see. So what we're going to do, we'll plug it in. And we'll take down some parameters, get it plugged into the gear. He's provided a microphone with it because it's an unusual pinout. In fact, I think it's a pinout that's unique to this type of set. I'll just deal with that, you know, because that is presenting as a little bit loose. So if I can find, you know what, I'll put this away from a previous job. Let's put that away from a previous job. I will have to print out a service manual. I never think I'm going to see another one, so I'll throw them all away. So the springiness just needs a bit of tensioning up, because otherwise you can end up with a bad connection, and then Mr. Chippie will get to scratchy corner and he'll go think, he'll say, "Is that thing on full power?" And I'll go, "Yes, Mr. Chippie." You know what? I never noticed them have a 13.2 volt jack on them before. I've been doing these 40 years. That totally changes the way we can tune these. Then on the back you've got external speaker, public address speaker, and tape recorder. And a bit like the grandstand bass, it only records the receive side. It doesn't do the transmit side, which is a shame, because it would only have taken a capacitor to do that. What a shame. As the saying says, the ship was spoilt for the ship was lost for a ha'porth of tar. Avalanche of things. Right, we're plugged in, we'll switch on, it's on 34, let's put that on 20. You know what we'll do, just see what the power is, and then we'll go to 13 watts socket. But in the meantime I will have to print out the service manual. I'm going to have to print out the instruction book so we know what the polarity of that is, because it doesn't say on the back, which is disappointing. Right, so we need the microphone, which rattles a whole pile of mics across the speaker. which is going to be vital to this operation. It's a new one, and which is bought in, and I'm going to find it. Right, so it's come with a Capo DMC520, which there shouldn't be any problems whatsoever with. It's going to have to have been custom wired, because these are the only sets that I'm aware of that have this pin out. Good. Hang on a minute. The screw which secures the plug has broken through the hole. It's going to need a new plug, isn't it? New mic, not as new as it ought to be. Right, let's put picture in picture on. We'll show the main meter. We'll put it in the right camera bank. Selection 1 is the broadcast camera, which is ceiling mounted above me, and then the rest of it, all the others are on another switcher. So it's camera bank 2, camera 1. Hey! There we are. Right, channel 20, I've put the test set into low power, which is 3 watts, and you know what we're going to do first. I've got you all on the edge of the seat, like the Doctor Who monsters about to get you. Plug that into PA, which will tell us whether this is wired right. Testing 1, 2, well, let's press PA. Testing 1, 2, testing 1, 2. Right. When in PA, that's interesting, PA comes through the PA speaker, not through the internal speaker. That's fair enough, monitor the CB. Right, where's my pen gone? Meter lamp, PA function, faulty mic plug. Transmit. 2.8 watts. .7 watts. No transmit on channel 1. So the VCO's out, isn't it? So, what does it come in on at? So we'll try channel 5. No. Channel 10. No TX on channels under 19. Go back to channel 20. See what the deviation is on this test set. Wow, look, it says 4 on there, which is probably what it is. I'll switch the other test set on, and then by the time we're ready to do deviation, that will have warmed up. Frequency We want camera 2 on bank 2, so that's there. (79127), absolutely spot on. So it should be 2779125. It's 2779127. So it's just that tiny little bit high, which is absolutely ideal because they drop with age. So let's look at the S meter. Make sure we're on frequency. We are. So I've got 100 microvolts on the signal generator. And that should be 9 on the meter, which is too generous. It is 60, 70, 80 microvolts. No, it's not. It's 8 microvolts for S9. Very, very generous meter. And on transmit, let's go to transmit. The meter reads what? Regardless of what the output power is, it should be calibrated to say 4 on transmit. And it does. It's absolutely where you'd expect it to be. Because it's BS, isn't it? And newer sets are even more BS because they're just pre-programmed to read whatever. And I don't think there's any sets. If there's still some current production Midland 78s, they've got a normal older type of power meter where it's a relative power meter. But the new sets are just pre-programmed, and we've had many a set here with no transmit whatsoever because of a fault, and they're still swinging across saying they're transmitting because of the BS. If they can't be bothered to do it, you know, why bother? If they've got a TX light, that's all. It's become a glorified TX light. So RF is actually correct at the moment. Low power. Where is it? That's at the back. Low power should be 400 milliwatts, and it is 180 milliwatts. It's not adjustable on these. That will change in the tune-up. What else? Let's go to receive. So I need to plug the test equipment in. Do I need to put an earth on? I think I do. Not sure if we're going to be able to do that without taking the set apart. So I've had to clip the earth off our testing because of modern sets having funny arrangements. Let's see whether that's picking up. Yes, it is. Right. Sensitivity isn't usually crummy, it's just the bleed over. 0.82 microvolts. Actually sounds alright. Doesn't sound like it's been ruined like they often are. 0.68. 20. Does it ever do 20? It does. It does it at 3.35 microvolts. Squelch. Let's turn the squelch to full. And it comes in at 100 microvolts, exactly where I want it to. And then been AM squelch on this, like it is on the Fidelity 1000. They're a unique board in this, and it uses a Sanyo LC7137 as a synthesizer, whereas the Fidelity 1000 used that Motorola general purpose chip. So it's better synthesizer arrangement, but then the receiver's exactly the same as the Fidelity 1000. It's a totally different board, but that's the way it is. So you get Fidelity 1000 performance, but as a mains base station. But I'm surprised they didn't just do that same board in a base station. Anyway, they didn't. Then they produced this, and it is a unique style. Give them that. So we'll turn the signal generator to standby. Set squelch. We've parked the squelch at 0.3. We've parked the signal generator at 0.3. We'll switch it back on. Nearly came in, didn't it? It's 0.48. 0.48 microwatts. So on the face of it, the receiver isn't far out. I think we can improve this SINAD reading with setting this very strange detector arrangement. It doesn't use a clever FM chip. It's a different type of arrangement. You see ratio detector on this. So there we go. So we've got a VCO problem. We've got transmit exactly where you'd expect it to be. So really, we've got a VCO problem. That's it. So I've got to try and remember how to open it up. I'll switch it off. Before I do that, we're going to print off the service manual, we're going to print off the instruction book, and we're going to try and power this by the external power supply, and we'll see whether the power output changes with an external power supply. I don't know why I've never done this before, but I haven't. Right, let's get a bit further with this. Instructions, service manual. So whilst this 13.8 volts input done, insert the adapter into a CB. Right. Well, that was not helpful. I've got to go and collect that, and I've put it in with it. We've got no circuit with this. You know, everything's got to be. I seem to have to do everything double checked. Right, well, we'll do so. It's customer set, but we would never normally do this, but we're going to just plug it in at assume it's center positive. Oh, of course, our connector doesn't fit. Okay, that's the end of that idea. It must be 2.5mm, not 2.1mm. And that one's totally inadequate. It does fit, but it's only capable of half an amp. Okay. Take it apart. I'll get Mr. Chippie to make up a custom lead to test these in the future. But, he won't be here till later, and we may be going to Sheffield today to pick up some records that I bought. Some vendors are very, very slow. I emailed them 10 o'clock last night after I'd won the auction. and it's now 11:45 and I haven't had a reply about can I collect today please. You know, if you're selling things, you really need to, I mean, I don't do mobile phones, so it may be, I may not see emails for up to 4 hours. But you need to be on the ball. We pull all the knobs off these, don't we? Oh, we're going to have to get the string out as well. Unplug it from the mains. You can see where they're being forced off with a screwdriver underneath. It's not what we do. Wrong screw. Wrong screw. So the two same wrong screws are at the end. Ah. We do get a generous... Oh, well, it's knocked all the meters. You get a generous lead, but I'm not sure it's generous enough. So I think we'll do the power supply capacitors, but it's an awful lot of work. And to be honest, I think we need to start by doing that. Just disconnect that speaker. It's about a 4-inch speaker on these. It's about the most generous speaker in an ECB. But then these boxes also got used to, they did a medium long wave VHF entertainment radio, didn't they? What's happened there? Right, how many millions of screws do we have to take out? Who thinks they owned a screw factory as well? Can't even get to tap with those. Connect the aerial socket. If you've ever got to change any parts, you've got to do all this. Yay! Yay! So that's about, it's like a clamshell, isn't it? But we can get to these capacitors. At 25 volts. I'll have to print off a circuit diagram. If you want to get the board out further, you'd have to disconnect the microphone socket and all the power supply wiring. So 1000 at 25 volts. I'll have a look at the circuit diagram because I think they're in different positions. I'll go for lunch. Right, I've got the circuit diagram now. What we're going to do, change the 2000s to 2200. You can see that our one on the right, which is 2200, is actually smaller than the 1000 that we've taken out. So we're putting 2,200 at 35 volts in. I've taken out 1,000 at 25 volts. So we'll get both those changed. I would not want to go over 4,700 in total, and we're not doing that. Ideally, I think instead of 1,000, perhaps 1,500 each, but they'd have to be ordered in and they'd cost more. So there we go. Right, I'll get those in. The other thing we're going to do is, that's the 1,000 there, 1,000 there. Just as a precaution, we'll change the 10 there and the 10 there, because at the end of the day it's 40 odd years old. We'll do these first, because I don't have to take this board out ever again. I'll tell you what, let's get rid of some of this glue from underneath, because that can be a problem. Right, time to plug it in and see if the power supply still works. See how many volts it is. It's not adjustable, so what you get is what you get. I've put the aerial socket back on. I've put 2 screws in the board, and that's all. How's it powered? Where is the output, in other words? Well, one end of the lamp is straight across it. Because I can't get to that, can I? Well, if it is there, it's 13.5, which is what you'd expect. Can we see where the meter goes to? If it's the yellow wire, which is positive, .5, so that's absolutely fine. So we've put the 2 10 microfarad capacitors here. We'll put the 2 new 2200s there. I'll just get this connected to the test set, because I want to see what the voltage drop is in transmit. It is connected to the test set. Just plug the mic in. The mic with the dodgy plug. I'll ask the customer whether he wants us to replace that, for which will be a fee, or whether he wants to sort it out himself. Right, let's get that. We need an earth, don't we, because we're not getting anywhere without. We're going to have to do the VCO. Well, we could probably put it to that can, our earth. 13.5, key up, 13.4. So it's not being loaded down too scarily. Right. So put that circuit to one side. We'll keep the meter out because we're going to have to do the VCO. Now, they want you to do the receiver with the sweep generator. We've shown this a couple of times on the bench behind me a few years ago, but it's pointless because we've got SINAD meter, which is better. So when there weren't SINAD meters, then the method they use is fine. So this is the one, and it does start off with this. Select channel 20 in receive, and they want you to connect an oscilloscope to pin 14 for logic high. Well, we can use the electronic voltmeter because it's an electronic voltmeter, it's not loading the circuit down. If we used an AVO 8 traditional meter, we would be loading the circuit down, so that wouldn't work out. So, do we have to go into the phase lock loop department? Yes, Mr. Tango, of course we do. Right, we'll switch it off. There's no sign of what that strange case hole was about. We have to take this screw out because the bracket is screwed from the inside. Hey, we're there. So it says pin 14, let's put power back on, channel 20, and we're wanting logic high, which I'm sure it's doing, otherwise it won't work. So pin 1, 2 is 20 pin chip, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 7.3 volts. It says, you know, you're expecting but in fact, of course, it isn't right. It's a very simplistic way of doing it. We're going to have to, because we know that at 22, isn't it, it doesn't transmit. 1, 2, 3, 4. What are we adjusting? TC1 on transmit. So going to transmit. I'm going to put it on low pass so we don't heat the transmitter up. And I've got to just check which trimmer capacitor is which. So I can't see which is TC1 and TC2 from here. Well, TC2 is that one. TC1 is that one. Yeah, because TC2 is going to be the frequency, whereas TC1 is the VCO. Pin 14. (11, 12, 13, 14). hopefully that's in the centre of the lock point. So we've definitely got lock on there. Let's change channel. We've got lock on channel 40, and we've got lock on channel 1. And we've checked it in receive as well. So it's not as good a method as what you have with the Cybernet 134s and the Unidens and the Cybernet 002Fs. You're just looking for... It's a bit as rubbish a setup as the DNT, where you've got to just monitor for when the chip is in lock, instead of it being a specific voltage. So you're looking for logic high, as it says on pin 14. So that's that, we're done. Pin 20 should be logic low, when transmitting. Which it is. It wouldn't be transmitted if it wasn't. So that's the problem sorted. That's why it's here. Alright, we'll go back to full power on transmit. I'll put the meter away. You can hear the air conditioning keep coming in. Well, it's quite a hot day here. It's about 31 degrees out. That's 31 centigrade. Transmit. Channel 20, adjust 6, 8, 9 and 10 for maximum. So 6, 8, 9 and 10. I think 6 is this one. Yeah, it will be. It's just the writing's on top of the writing. So we're doing 2.9 watts now at full power, and that's probably more than it was. Let's go back to our clipboard. Yeah, it's gone up 0.1, despite me having been in transmit and warmed it up a bit, because the power supply is working better. Now, trying to get to these other coils is absolutely ridiculous. Before, you know what, we've actually taken the controls off before to get to these. I'm assuming the boards are aligned at the factory before they put the wiring in. They can do that using a pin jig. That's definitely at peak. So far, everything has been correctly at peak. There's also one there. And that's also at peak. So we're at 3 watts. Let's see what we do next. we'll check where we are with the frequency. $79133. I'll just pop it down a fraction. They're actually good quality trimmers. That's absolutely spot on. We normally have it a tiny bit high, but if it happens to land spot on, well, that's fine. So that's now done. Going on with the transmitter, it's L68910, which we've done 68910. So we add to that 11 and 13. 11 and 13. And you set the power on 15. I think we're gonna have to pull this. I'll turn it off. I mean, they never intended to do this, do they? If I remember rightly, what do we have to remove? I think it's the button bank. See what we will do, we'll put back the shield plate. No, it's not going to happen. that one done. Make sure I'm doing that one, and L15, which we haven't yet got to. If we take this bracket off from the top, I can't even see what shape this is. I don't know whether it's broken or I've just not got the right tool or what. That's that plastic set. That's it, we're imperfect with that one. So it's the green tool. And there's no difference because it's all the tuning so far has been spot on. I think the only thing that's made a difference is the power supply. So now the meter's saying, you can't kind of quite see that, but it's now swinging across to nearly 5. So the next thing I want to do is the deviation, and we're looking for SVR2. SVR2 is there, and that looks to me like it's at full whack. Let's put the tool in there ready, and we'll go to the meter behind me. And I've no doubt that when we read 4 kilohertz it was. 1, 5. Right. That works well then, doesn't it? 1, low. Talkie on.
Testing 1, 2, 3, 4, 5.
See what the deviation says on the Marconi test meter. I expect it's lying today. 1. It's saying 2, so it's not right today, which is why we're not using it. Right, that's that done. So that was 5. Now 2.2 to 2.5 kilohertz. We've got 3.1 watts on channel 20. Let's do the other channels. Channel 40. Um, 2.9. Channel 1. 2.8. Channel 20. Tell you what, we'll go to the lower scale, make this easier. So it's 3.1 there. Channel 1, 2.9. Channel 40. 2.9. So really got that in the middle. And remember, this is on the commercial test set, so all these figures will be a lot closer to 4 than you think. Low power. Non-adjustable. Let's see what it is now. 180 milliwatts. It's not changed at all. RF meter, we're going to need to adjust that because it's going to look like it's on steroids. It doesn't tell us this, does it? Does it tell us this ever? Receive, receive, receive. No, of course it doesn't tell us. So we'll have to look at the square kit diagram. We've got a Uniden 300 base station tomorrow, and it's had the kiss of stupid amount of useless non-working channels. So it's here for demodification. See if we can get it to work again. Hope it hasn't killed the phase lock loop chip. So we're looking at the transmitter. The transmitter is here, and we're looking to how they do this meter. I think it's tapped off there. I think it's going to be that. SVR3. So if we can find SVR3 and twiddle it, that should be the meter. SVR1. Not sure. 1 and 4 as correctly said. Two was deviation. It's right down at the front. You take the meter out. I knew there was something you took the meter out for. It's there. So we can see the meter. We set that to 4 even though the radio is doing 3.1. It's all psychological. Right, so now we do the receiver, which is the hard bit. So we're not doing the sweep generator method shown in here. We're going to do it's 5 and 6 of the detector. Right, let's put some volume on. Do I have to plug an external speaker in, folks? Yeah, I do, don't I? I think it was the second one along as well. And we need an earth. Which can be that can. Is that the right socket? No. That's the right socket. Okay, what are those? RF gain wants to be at full, calibrate is an important, tone set to centre. That's it. .100 microvolts on the signal generator. And we're looking for 5 and 6 at the moment to do the, let's put the oscilloscope up, to do that. Let's put a decent trace on, like that, 5 and 6. It's those two at the back. And this is why a lot of these sets don't work as well as they could, because unless you've got some decent test equipment, you're just going to mess it up. See, that was out. And the IF is 3 and 4. Well, 3 and 4. I think it's that one and something nearby. 3 and 4. On to it is. Let's go back to that. Right, front end. I think it's T1 and 2 to be honest. Drop the signal. There we go. On the extension speaker on the wall rather than through the test gear. It's definitely moving. Anyway, I'll come back to that. Right, we need to set the squelch on this. This preset for squelch is... No, sorry, we'll do the meter first. S9 should be there. So that's now on the 9 for 100 microvolt signal input. I also want the squelch to have opened at this point. Like that. Well, that seems sensitive enough. It's coming in. Squelch is coming in at 0.76. What else did we want to do? Oh, see what the sensitivity is. Let's go back to the test equipment speaker. Go to the SINAD meter. I've got 0.42. That's weird. Something's changed. Depends on whether you let light into it or not. Okay, so now we've got 0.42 there, and now we've got 0.48. We've got 1. Actually, I'm being a bit kind there. Change scales. Ah, yeah, it is 1. Yeah, it says 1 both both scale serves one. Let's just put it on the aerial and see if we can call Mr. Chippie in the next room. You don't normally have to do these kind of things because once you've set them up on the instruments, you've set them up, but on these it's so unpredictable. Tango 21, oops. I have to go to...
Go again.
I've got the extension speaker on, so I've got a permanent earth on the extension speaker, so I'll give myself seat feedback. So when I let go of the mic, I'll connect the extension speaker back to earth.
Yeah, right, sir.
Oh, that's working fine. Great.
Good.
Right, so I'll just plug the ordinary speaker in, folks, and I think we're done. One and a Roger. Well, I mean, that must be coming in from 35 miles away, but chances are they're on the burner anyway. Right, well, as far as I can see, we're done. But dare I put all the screws in? I don't know who the bloke is who keeps calling Tracy. Right, that's all the screws back in. So, you know, I love some of these vintage sets. You've got to appreciate that the performance of these is poor. You know, if we compared this to any other base station, I mean, even those Murphy ones work better than these. But I do appreciate people wanting to have these serviced. But you can't have it as your only CB radio, honestly. Right. I was given one of these about 10 months ago, so I think we'll try and pull my one in. We could sell that then, couldn't we? It was sent as a donation. So we'll see whether matey can do some knobs, and we'll see whether I can find some. I tell you what, by the time we come to the next one, and try and do it in the next 10 days, I'll see if I've got Mr. Chippie to make a power lead up, so we can do it off the bench power supply, and then we can monitor current. So this should be far and away better on the way it hums. I mean, I didn't monitor it before, but the customer says it hums. It's going to be better. ramp it up a bit more. Hopefully you can see that. Make sure picture's off. There we go. So if we press calibrate and key up, bit of a dirty potentiometer, that. So that's giving us an SPR of like 1.1 or something like that. So that's actually fine. We'll just waggle that around a bit. Try calibrate again. STBR's working fine. Right, so that was a point he'd mentioned. So we've got wrong screws there. And there. Just kind of put those in snug for now. And then you've got the screws in the back. To be honest, I think they're all supposed to be countersunk, so I think all the screws are wrong. Still final checking with Mr. Chippie. Mr. Chippie, a quick test for the video.
Yeah, Roger, you're loud and clear. Testing 1, 2, 3, 4, 5, 6.
Roger, thank you. Good. And when you press channel 9, the display is distinguished and you get the little LED on the front panel instead. Right, I'm not testing the headphone socket. We're not retail, you know. So we have it, the Fidelity CB3000. We're doing on the air test to that this evening. And tomorrow we will do Uniden 300 base station if we can get it to work after it having had all the stupid modifications and the kiss of death. Thank you for watching.